We did section 4.1 to 4.3, whatever. Most of you guys took that quiz. In 4.3, there was at least one proof where you guys had to prove the triangle's congruent. But how many pieces of information did you have to show? More than that. Six. 3 sets of sides and 3 sets of angles, which is a lot, okay? Instead, Mrs. Rep taught you guys yesterday that you can prove triangles congruent just by showing 3 specific things, okay? So there was 2 methods that you guys had to prove triangles congruent. What were those methods from yesterday?
Side angle, side.
Good. So side angle, side, and then side, side, side. So those were the 2 methods that you guys had to show triangles to be congruent, okay? Which was nice because then you only had to show 3 things, okay? All right, but you still had to go through a proof of doing those, so that took a little bit of work at times, okay? All right, so let's go through. Let's start with our first one. It's always easier when those triangles are like actually connected to each other, but it's not what happens for the first one. So statements and reasons. Oh my gosh, it's so nice to write with a stylus again. My plan this week is today I'll do 4-5 with you guys, and then I'm going to quiz you guys on Friday. So 4-4, 4-5, all the way on Friday. So we'll spend a couple days reviewing and going over stuff. And I'm also going to give you guys a cheat sheet, not to use on the quiz, but to help you guys when you guys do your homework. We'll do that tomorrow, I think. Okay. All right, so PR congruent to DE. We have a lot of givens for this one. PT congruent to DF. And then angle R is congruent to angle E. And then angle T is congruent to angle F. So, given. All right, so they gave us 2 sets of sides congruent and 2 sets of angles congruent, and then they show that in the picture itself. So they have those already marked, okay? But just based on what they give me, is that enough, like in that picture, is that enough for side, side, side?
Yeah.
No, stop it. We're missing a last set of sides, right? Is it enough for side, angle, side? Do I have 2 sides in the angle that connects them?
I don't think so. Yeah.
No, I don't. I have 2 angles in the picture, but the angle that I would want that connects the 2 sides that I know would need to be this angle and that angle, because that angle is between the 2 sides that I know. And I don't know it. So because of that, I don't have enough for either one right now, okay? Is there any way for me to get that last remaining set of sides congruent, RT and EF?
Third angles there.
Ah, that would be for angles, right? But Raph is right. That's the next thing that I'm going to do, is I can say that angle P is congruent to angle D by third angles theorem. So next thing I'm going to say is angle P congruent to angle D. And then we did indeed have a theorem that said if I know 2 angles of one triangle congruent to 2 angles of another, then the third set of angles is congruent. So I'm going to say third angles theorem.
Wait, what does the theorem? Wait, what does it prove?
If 2 angles of one triangle, like I have here, R and E and then F and T, if 2 angles of one triangle are congruent to 2 angles of another, then the last set of angles also has to be congruent. All right, now that I've done that, I now have enough to prove the triangle's congruent. I have 2 sets of sides and the angle that connects those, so I'm going to use side, angle, side. So then my reason for that is I'm going to copy down exactly as they gave me. PRT is congruent to triangle DEF, and then my reason for that is side, angle, side theorem. Okay. I give you a lot of givens for that one. All right, let's do 2. The less givens they give you, the more interesting the problem is.
Does it also make it shorter?
No, usually when they give you more givens, it's shorter because then there's less things that you need to show, but that's not always the case either. This one isn't long though, so RS is congruent to TS is a given, and then your other given is V is midpoint of RT. Yeah, I'm just going to write that on a line since I'm using it anyway. V is midpoint of RT. And then the reason for that is given. They only gave me one thing is congruent in my given statements, and it's already shown in the picture. So the next thing I want to do is I want to use my given. Jillian, what do you think? When I say midpoint, you guys say two congruent parts. And V is the midpoint of RT is going to give us that RV is congruent to VT. Very good. What reason, Jillian?
Definition.
Of? Correct. Okay. Now I've got two sets of sides. I've used all my givens for all that they're worth. Okay? From there, when you've run out of givens to use, like vocabulary word and givens, now you need to go to your picture. There are two things that you can get for free for most of your pictures. One of them is in this one. What can we get for free?
Reflectives.
Good. Yeah, reflexive side, right? I could say VS is congruent to VS. And then the reason for that is reflexive property. All right, there's a side, there's a side, there's a side. Did I show enough pieces of information?
Not yet.
Yeah, I did.
SSS.
Yep. Triangle RSV is congruent to triangle TSV. I should say, did I show enough pieces of information to then write my congruent statement? That answer is yes. And then, like Jillian said, side theorem. Parker, you with us?
Yes.
Be with us, buddy. This is not a section that I can like walk around and police you guys on your iPad. I just like, you got to be with it, okay? Not something that you can BS your way through. All right, so I showed three sides of one triangle congruent to three sides of another, so I can then say that those triangles are going to be congruent, okay? All right, now, number 3, not very fun. What do you have to do for number 3?
I have an idea.
Distance formula. What's your idea, Jillian?
This is what I did, but my group, we kind of did it differently. I did
Your what did it differently?
our group.
What group? What's that mean?
Our group.
Oh, like when you guys were working on it? Okay.
So I started with DE, and then I found the sides of PQ. Like I did it. Like I guess you could just find all the sides from the same thing.
Like, what did you use to find the sides?
It's a formula.
Distance formula, right? How many times do you have to do distance formula? 6 times. That's a lot.
I just plugged it in the calculator. I didn't do it.
What do you mean plug it in the calculator?
No, like I just wrote it like the equation in the calculator, and then I just wrote whatever equation it gave me, or whatever it gave me.
The sub was doing them in his head.
Yeah.
What a legend.
He would not leave us alone. He'd come over here, just continuously come over here, just like talk. Like, he thought that he was doing something. It was just annoying.
It was just like.
Oh man, this guy's just trying to help you guys out.
No, he was just like, I did this in my head, and I was like, good for you. Like I don't. Good for you.
All right, well, either way, you don't have to do them in your head. But,
Is there a way to do it in your head?
I mean,
If I show you one, could you do it?
yeah, probably, but like I'm not going to, you know. Either way, so we would do distance formula 6 times in order to find the length of each one of those sides. And then you would just need to show that those sides are the same. And then you could say that those triangles are congruent by side. I'm not going to show that one out. But let's talk about 4, 5, and 6, then we'll do these theorems in the back, these proofs in the back. 19 is a bit of a tricky one. Is there enough information to prove those triangles congruent?
No,
No.
For number 4, you say no? Why not?
because it's only showing that you got
No,
Yeah.
actually, I think there is.
Well, we could say this, right? The problem is we wouldn't be able to get any of the other sides. So I would say no, not enough info.
But don't you know the outside ones are congruent, and then the middle ones are congruent?
What you talk about outside ones?
No, like there's the 2 on the right. There's these 2. and
Yeah.
then there's this one. So if these all are congruent, then that means that.
I don't know that they're congruent though.
Well, it's a vertical angle, no?
And that tells me these angles,
Well,
That I
the
marked.
2 dashes on the over there.
these dashes.
Yeah.
These are sides, my guy. So I have one set of sides and one set of
Yeah,
angles.
they're equal.
The sides are cool. So that's 2 pieces of information. I would need to have a third set to at least have a chance, and I don't have anything. So not enough info. What about 5?
Yeah.
Okay. So I have 2 sets of sides, and then I have this is a right angle, right? Which type of angle is this? Also right angle.
Yeah.
What other set? Well, that alone is not enough. Because is that angle between the 2 sides that I know?
No.
No, it's not. So what would be my last set that I'd need? I'd also need the middle. I'd also need to mark my reflexive side.
Isn't that the middle though?
What?
The 90 degrees, the right angle.
I mean, it's the middle of like the bottom. I just mean like
Doesn't that
this
mean the
middle
of
side
the
length.
middle is also the same. Wait, what are you making? Oh, never mind.
You good?
Sure.
All right, that'd be yes by side angle side. So it needs a third mark there. Because then I would have, if I do it a different color, then I'd have this side, and then this side, and then the angle that connects the 2. So that would be side angle side. What about 6?
SSS.
Yeah.
Side, side, side?
Yes, sir.
By that reflexive side down Main Street there?
Do you know?
Let's do 7. All right. So we got a couple given statements here. Let's copy them all down. At first glance, this looks like the easiest proof of all time because they give you 3 sets of sides congruent. The problem is the triangles they want you to prove don't necessarily go along with the 3 sides that they give you. So like it's marked in the picture which 3 sides that they give you congruent. The problem is they want you to show triangle AFB is congruent to triangle EBC. Or ECB, rather. It was barely any better.
Sure.
If you separate those triangles out, so like 1, 2, 3, and then 1, 2. Let's see if I can do this. I don't know how I do this. But if I separate that out, all I know of that bigger triangle is this side and this side. I don't have all of the bottom. I only have this 1 tick mark right there. Okay? And then same thing with that other triangle. I don't have all of that bottom. I just have that tick mark that goes with FC. Okay? All right, so here's a question. This blue side that I kind of highlighted here, like along here, what is that side made up of?
The 2 sides.
AE and EF, right?
Yes, sir.
What about the other one in the red triangle? What is that made up
The
of?
same thing.
EF, which we just had, and then FC. So they both have EF in common, okay? So what I really need to do is I need to show that those 2 bottom segments are congruent to each other, and then I would have all 3 pieces of that triangle, okay? All right. Now, in order to break apart segments and add them together, SAP, we got to use segment addition postulate here, okay? So I'm going to do that. I'm going to say that AF is congruent to AE plus EF. AE plus EF. And then I'm going to do the same thing with my other segment. I'm going to say that EC is congruent to EF plus FC. All right, well, I know that AE is congruent to CF. That was one of my givens, right?
Yes.
What could I add to both sides of that congruent statement?
AF.
Not AF,
EF.
EF.
Yeah.
And then it would be the same thing, right? So then I can say that instead of just AE is congruent to CF, I can say that AE plus EF is congruent to EF plus CF. And then what did I do? I just added, sorry, I can zoom in so you guys can see it, but I just added EF to both sides. So I'm going to say addition property. But what is AE plus EF?
AF.
It's AF. So next thing I'm going to say is AF, just by substituting that in there, is congruent to what's EF plus CF?
CF.
CE.
CE.
Nailed it. So we can say EC or whatever. And then my reason for that would be
Transitive.
good, substitution. Transitive would work though, too. Either one would be fine.
Oh.
That'd be okay with it. All right. Now have I shown all three sets of sides?
Yes, sir.
Yeah, so now I can say that those triangles are congruent. So I can say that triangle, where's it at? AFB and CEB. And then our reason for that was side, side, side theorem. So that one ended up being longer than I thought. At first glance, I was like, oh, sick. They give us three sets of sides congruent. Nope. All right, I'm going to do number 8 with you guys. Just do them all.
Don't start this BS part.
And he's already on his BS. So X is midpoint of BD. And then X is midpoint of AC. Given. They didn't give us any things congruent in our given statement. They just told us that I've got midpoints, okay? When I say midpoint, you guys say,
Two equal parts.
you're ready for it. So what would be my equal parts then? X is midpoint of BD.
DX and DX.
BX and DX.
CY and AY.
You mean CX and AX, right?
Yeah, what am I talking
I don't know. So we're going to say DX is congruent to BX. And then AX is congruent to CX. It's D. And then our reason for that would be what?
BA.
Nice.
F.
Definition of midpoint.
Should be goes not right here.
How many sides did that give us? 2 sides, right? I just need to show one more piece of information, ideally. What triangles am I even showing congruent? DXC, so this guy. And then the one right next to it,
BXA.
BXA. So then, what other piece of information can I get? Where am I going to go from there? I've used my givens.
Just make them congruent. Substitute.
I need a third piece.
Oh.
Vertical angles. So I know that in the middle, those angles are going to be vertical to each other. So we have to list that out with 3 letters though, because there's 2x. You said what?
How did AXB and DXC?
AXB and DXC. So we would say angle AXB is congruent to angle DXC. And then Molly told us vertical angles. So vertical angles theorem. Okay, I showed 2 sides at an angle. You guys told me angle, side, angle. I think you did. Did you guys tell me angle, side, angle?
No.
Surprise! So triangle DXC is congruent to triangle BXA.
Is there one that's 2 angles and then one side?
Yep, angle, angle, side, and angle, side,
What
angle.
about all A's?
Nope, can't do all A's.
Why?
I'll talk about that in a minute. But that would be, what did we say? Side, angle, side. Theorem. Raf is perfectly transitioning us into what we're going to talk about today.
Can I go to the bathroom?
Can you do it in 90 seconds?
No.
I made Carter do it in 90 seconds.
Okay.
You got to do it, 90 seconds. You better strap your Lamborghinis on. All right, section 4.5. Notes are on Google Classroom. Go ahead and pull those up, please. A free day tomorrow. Elena, if you haven't noticed, Mr. P doesn't give free days.
You have it in all your years of teaching, but I feel like you should make an exception for us since you're here in class.
You guys are a very special class. Although, on the sub note, it did say the day went very well. Except 5th period was a little more chatty than the rest.
That's not true.
I know, I was surprised to hear that you weren't here. Because I feel like you have an element of distraction sometimes in our class.
No, I kind of control it.
Is that what it is?
I know.
Okay. But either way,
They call me the alpha around here.
do they? Who calls you that?
You know.
Who calls you that? All right, so today we'll talk about what. Oh man, I have to go through and delete all these.
No, Emma looked this up yesterday.
What?
CBE.
CBCTC? Yeah. It's not that big of a deal though. I promise. Like CBCTC is pretty simple.
You say it very fast.
CBCTC,
That's what the teacher, like the video was using.
Mrs. Rep,
Yeah, CBE.
CPCTC. We've technically learned about CPCTC already. Look, this is what it looks like when I have to write a proof without a stylus.
It's not that bad.
Really? Woof.
Mr.
It was uncomfortable writing it. What?
We got bad news. My notes won't load, so we can't do it.
Chalk it up, guys. Pack it in. We are done.
Guess we have to watch it.
What should we watch? Marley and Me? Can I tell you a story about Marley and Me?
Go ahead.
You guys know that movie, Marley and Me?
Is
Yes.
that like the dog one?
Yeah, where like they get like a puppy and it's like super misbehaved or whatever.
Were you in the movie?
I wasn't in the movie.
Oh.
But I went to see that movie on a first date. And I like it's a good movie or whatever. It's got like Owen Wilson in it or whatever, so it's funny. But like the dog dies, right? Spoiler alert, the dog dies at the end. So anyway, we're watching this movie and I'm on a first date and the end comes and I'm like, like I'm bawling my eyes out. Because I just put my dog to sleep like 4 days before that. Why did I go see a movie about a dog?
Why would you take a first date to a movie anyways, though?
Because this was like 2008 or something. I don't know.
You're ancient, aren't
Yeah,
you?
where else would wait, yeah, that's a good point.
Is she bad?
So stupid. Yeah.
Huh?
Is she bad?
Why are you talking?
We dated for a while.
Wow.
Whoa.
What was that supposed to
And then happily ever
be?
after.
So serious.
No happily ever after there, but that's all right. Okay. Anyway, enough about any of that. What'd you say?
When did you meet your wife?
I don't know.
What?
What year was it? 2013 or something? No, 2012. I think we met.
How
So-
old were you? Or like, were you like in college?
I was in college. I was 20. I think you were just turned like 21 or something like that. So.
Wait, how long did you teach at Norton?
A long time. All right, here we go. So, so far, what congruence methods have we learned? What did we talk about? SAS
ASS.
and
Yes.
Oh, wait, ASA.
yes, not SASS. We are going to talk about ASS today a little bit, though. We refer to it as SSA, but we will talk about that a little bit today. Okay. So far, we've shown if I should know 3 sides of one triangle congruent to 3 sides of another, cool, triangles are congruent. If I know 2 sides of one triangle are congruent to 2 sides of another and the included angle, cool, congruent, okay? Today, we're going to talk about ASA and AAS. So yes, Raph, if you know 2 angles of a triangle and a side, you can prove that the triangles are congruent. ASA is pretty similar to side angle side in such that the side has to connect the 2 angles. In side angle side, it was the angle had to connect the 2 sides. In angle side angle, the side has to connect the 2 angles, okay? And then the other one that we can show is angle side. That one's a little bit more open-ended in such that the side does not have to be between those 2 angles. And I'll talk about why that happens, okay? So here's the statement of angle side. If 2 angles in the non-included, that's an important part, non-included, side of one triangle are congruent to the corresponding 2 angles in a side of a second triangle, then the 2 triangles are congruent. So same type of thought process As long as you can show two sets of angles and a corresponding side, then you can say that the triangles are then congruent to each other, okay? And then the other one that kind of goes off that down below is angle side angle. So, thanks, Jillian. So if two angles in the included side of one triangle are congruent to the corresponding two angles in the included side of another, then the two triangles are congruent to each other, okay? The key is you have to show the side that's connecting those two angles for it to be angle side angle, okay? All right, let me talk about this real quick. So this is angle side. If you can show two angles of one triangle and a side of the other and it's all corresponding, what could we technically say about that third set of angles? They'd be congruent by third angles theorem, right? So B and E would be congruent by third angles theorem. And then if I had that, you could show that the triangles are congruent by angle side angle. Do you see it along the line there? So that's why angle side works, okay? All right, so let's do a bunch of examples using that, okay? Can the triangles be proven congruent with the information? If so, which postulate or theorem you could use, okay? So not only will we use the ones that I just taught you 40 seconds ago, but we can also use the ones from last section as well, okay? What do you think about number one?
Yes.
Yes, why?
Because you have enough. It's SAA. You have two angles and then one side.
Okay, which technique would it be? We do have two angles on the side.
ASS.
Not ASS,
SAS.
not SAS,
ASS.
not ASS again,
SAS.
not SAS. ASA sounds good. So it'd be yes by ASA.
Oh my days.
Oh my days, it's the side between these two angles. Man just kept coming back to that one. I don't. All right, what about number two?
No. Oh yes.
Why yes, Brielle? Good. The side that they show you does not connect the two angles. So it'd be yes by angle side. Very good. All right. What about number three?
Yes.
No.
I hear yes, I hear no.
Wait, I forgot what we're trying to prove though.
I just want to prove that triangles are congruent.
Well, they are.
How do I know that?
Because of the angles, like the lines that you can see.
So that would allude to AAA, right? Angle. There is no
What about
AAA.
third angles? Okay. Theorem.
No, I mean, if I knew two angles, I could get the third by third angles theorem, but it doesn't help me here. I have to have one of the sides. AAA is not a thing. Let's talk about why that's the case, okay? So we'd say no, not enough info. I mean, Jillian pointed out angle, because that's all we have is angles. We don't have any sides. So let me do this, like off to the side or whatever. Let's say I have... no, let's use technology. Let's say I have, whatever. This very straight-sided triangle. I don't like that either. Get together, Mr. P. Okay. All right. So let's say we have this triangle right here, okay? Let's see if, I don't know how to do this. Wait, can I, boop, just do that. And then go copy. And then paste. And then, actually, let me do this, hold on.
You got it.
I did, I'm so close. So then let's say this is like, you know, this, three different angles, right? Okay, so then let's copy this, and then let's paste it, and then let's resize it, and do that. Whoa. Okay. Are all three angles the same?
Yes.
Are the side lengths the same?
No.
No.
Bum, bum.
We don't know.
Well, definitely not, right?
If
Well, yeah,
you-
but like we don't know.
If you forget about the other angles and just look at one at a time, they're equal.
That's true, but in order for triangles to be congruent, they have the same sides and angles. And though that is the same shape, it's not the same size. So they're not congruent to each other. They are what we would call similar triangles, which we will talk about in the future. So we'll get there. So angle, not a thing. All right, back to our regularly scheduled programming. What about number 4?
No.
Yes.
No.
Yes.
No,
Because you know, yeah.
you don't know the angles.
Triple sum.
Yeah.
Yeah, see, if you know two sides, you know one. The last one is congruent.
What do you got for me, Emma? Say it again.
Vertical.
Yeah.
SAS.
Mm-hmm. I can say that those angles are vertical to each other. So because of that, that's one thing I can get for free: vertical angles and reflexive sides. And then if I put those marks in there, I can say yes.
Did you say that last side is congruent to the other one?
I can't say that. Like initially,
No.
before I knew they were congruent, or
Yeah.
now that I know they're congruent.
Now that you know they're congruent.
Okay, now that I know that they're congruent. So like, let's say this, because this actually comes up later in the section. After you guys prove triangles are congruent, what do you know about all those corresponding pieces?
They're all the same.
They're all congruent, right? And that alludes to CPCTC. Remember we talked about that in the past? Corresponding parts of congruent triangles are congruent. That's what that alludes to. You can use CPCTC in order to show that pieces of triangles are congruent to each other. Okay?
DCC.
CPCTC.
CBC.
It's like what I say to a cat when I see it. You guys do that too? Just me? All right. You guys do it too? Okay. All right. Any stray cat in the neighborhood? I'm like,
Still just you.
and they come running? No. Alina says she does.
My grandma's watching cats in the backyard and stuff.
This is being recorded, by the way.
I know, big time. Yep. You can catch it on YouTube. Subscribe, like and subscribe. Smash that like. All right. Number 5. Can I prove those triangles are congruent?
No. Obviously
Yes,
not.
yes, you can.
Oh, they're all sides.
Oh my God.
Oh, SSS.
They're all
Yes.
sides.
Yes.
They look like angles. It'll get you.
SAP.
All right. All those sides are congruent to each other. So because of that, yes, we can say that the triangles are
Is
congruent.
there gonna be a proof?
Mr. P, can
Here we
I
go.
have the bathroom now? 89
What's in
seconds.
Oh my God.
Go.
89.
All right. I'm setting my timer. I'm not going to let you go during the class again if you don't work. All right. So 90 seconds. Minute 30. Okay. Here we go. Raph asked for a proof, so here we go.
What's
Oh, that's triangle.
All right. Let's list our givens. And then our other given, AB parallel to DE. Okay. Kira, you doing all right over there?
Yeah, I'm listening.
You guys tell me. Take the driver's seat. What do we
Two
got?
equal sides.
Okay, you guys see bisector, right? So we know 2 equal parts. So what is being bisected?
AD.
AD's doing the
Yeah,
bisecting.
no, it's bisecting BE.
Okay, so then what would be my congruent pieces?
AC and DC. Wait, why?
Because what is being bisected?
Oh no, so then BC and then EC.
Yes. So BC and EC, the cousins of ACDC.
And then AB is congruent. to
BC, EC. So hold on. What is our reason for BC is congruent to EC?
Bisect by definition of bisector.
Angle bisector.
Yep.
Angle bisector.
Oh, Carter's not allowed to go again.
What? There's no way it's already been a minute.
It's been a minute, 30 seconds. Time flies when you're doing math. Definition of segment bisector.
That's like it's really quick.
How long does it take to pee? It doesn't take that long.
And then you know that they're parallel.
Okay, so trying to correct the ship. We got those sides congruent. Awesome. So then what Raph is doing is looking at, okay, what else have I been given? And then how do I use that? So my lines that are parallel are AB and DE. And I mentioned this in the past, but if you are given parallel lines, what do we get from that typically?
Ooh. Yeah, they add up to equal
180.
They both.
You said what, Molly? Yep, we're going to get angles that are congruent. In this case, we're going to do alternate interior angles. Molly, what are my alternate interior angles?
A and D and B.
Good. A and D, and then also B and E. So I'm going to list them both. Angle A, and I'm cool with using one letter because there's just one angle there. So angle A congruent to angle D, and then angle B congruent to angle E. Am I dumb? E. And then Miss Molly is right, alternate interior angle theorem.
ASA. Oh, then you do ASA.
Is it nice not being pressed for time?
Yeah.
I bet it was. Okay, so then I have a side and then two angles. My picture's a bit noisy, so let me delete some stuff. But what theorem, I should have enough information there, right? What theorem would I use to prove these triangles congruent?
Third angle.
Not third angles.
ASA.
S.
No.
It's,
no.
I have two angles and a side, so it's either ASA or AAS.
It's ASA, no? Because you have the two angles and then the congruent side.
Is that side connecting my two angles?
Yeah.
No. Here's one angle here. Here's another angle there. That side is all the way over here.
That was 3 minutes.
It was. Your pass is revoked, Carter. Wasn't a minute, 30 seconds.
Well, I was knocking for like 10.
Oh, that's crazy. So anyway, it's not angle, side, angle. It's angle, angle, side. Because again, this side does not connect those two angles that they gave us, or that we proved, okay? So it's still it's still congruent, it's just angle, angle, side. Okay? So triangle ABC and DEC. So ABC, AP Calc is congruent to triangle DEC. And then our reason for that was angle, angle, side theorem. All right, questions there?
I have a question.
What's up, Jillian?
For the part where we like definition of bisectors,
Mm-hmm.
is it? I'm just confused on how this is closed.
Okay. So they give you in your given that AD bisects BE. So let me erase all this stuff in my picture. So it's really important to look at how they.
Oh, wait. Okay. Never mind.
You good?
Yeah.
That's why I asked Raph, like, what is being bisected?
I thought it said BC bisected AD.
Oh, okay.
Wait, I have another question.
What's up?
If like you found out that like AD or
Mhm.
no, BC is congruent to EC and then AB is congruent to DE, couldn't you just do the vertical angles and then that's SAS?
Well, let's see. So, like you said, just for, example purposes, these sides were congruent, right? And then let's say they gave you that these sides were congruent, right? And then if you did a vertical angle, okay, this is important. You tell me, which would it be?
ASA.
We have two sides and an angle.
Oh, SSA.
Yeah, but is SSA a thing?
No.
It's not. A or SAS is, but is that angle that we showed between the two sides?
No.
It's not. Those sides don't connect that angle or connect to that angle. Like AB is totally across from this guy right here. So because of that, I wouldn't be able to do that proof, okay? Now, that brings up a fantastic point. And again, Raph, the king of transitions, is going to talk about how, or that's him. And then that really like guides us into like what we're going to look at next, which is side-side angle, okay? So we talked about like, okay, this would be side-side angle. So is side-side angle actually a thing, okay? It turns out that it only is in certain cases, okay? So if I look at this applet right here, is it going to let me do it? Open link.
GeoGebra.
GeoGebra.
Wicked.
Yeah, so like if I have, so you'll see like if I know the length of two sides and then an angle that's between them. So like here's an angle and then here's the length of two sides, okay? If I take that angle over here, I take that side length and I take my other side length, I could make two congruent triangles. You guys agree that those are congruent triangles?
Yeah.
And the only constraints I had was an angle and the length of two sides.
How do you know they're the same size then?
Well, so let's look at this situation. So cool, there's the same side length, there's the same angle, there's the other side length as well too. I could take that angle here, could take that side length, and take that other side length that I know, but then I make, are those two triangles congruent?
No.
So side angle does not work. Or we find that it only works in certain situations, okay? The situation that side-side angle will work that we can bank on is what's called HL theorem, okay? So, is SSA a valid congruence method for triangles? Only if our triangles are right triangles, okay? Now, I didn't do a great job explaining this last period, so I'll do a better job with you guys. But in order to prove that two triangles are congruent, our last of our proof methods is called HL theorem. Even though it's called HL, showing that there are only two things, there are actually three things you need to show, okay? And I'll list them off to the side. So you need to show that H, which means your hypotenuses, are congruent. You need to show L, which is one pair legs congruent. And then the last thing you need to show, I'm going to put like a right triangle and circle that, is you need to state right triangles. Okay? So for HL theorem, those are the three things that you need to show. You need to show hypotenuses are congruent, one pair of legs are congruent, and you have to state that they are right triangles, which is kind of awkward. Okay? All right. So let's do it. So like, for example, in this, I have two right triangles there. I would have to be able to say that my hypotenuses are congruent. So I'd have to be able to say that these guys are congruent. And then one other pair of sides. And then I could say that those triangles were congruent. Jillian, what's up?
What was the last thing?
State right triangles. How do you know you have a right triangle?
The 90 degrees.
It's got to have a 90-degree angle, right? So usually what happens before you state that the triangles are right triangles is you have to state that they both have right angles in them, okay? Now, I think I mentioned this to you guys, but I'll say it again. I'm going to give you guys a cheat sheet that we're going to fill out tomorrow that'll help with a lot of this stuff, okay? It's like that word bank. It's the 5 proof techniques, so that's on there. And then we are going to fill out a bunch of, you'll see how it's laid out, but I have it laid out for givens, statements, and reasons. So if you're given this, here's the statement that you can say from it, and here's the reason that you can say from it. Parker, what's up?
So you call it a cheat sheet, but we can't use it on the quiz. It's notes. It's just notes.
Reference sheet. It is I think it's actually titled, like the document is titled Proof Reference Sheet.
Notes.
It'll help you memorize things, I think. But yeah, I can't, like, you're not going to use it on the quiz, so.
None of this makes any sense.
Well, none of what makes any sense.
Any of this other stuff.
Okay. All of you are going to be my helper for this next one. List your givens. What does that symbol mean right there? Good. Okay. I only have 2 given statements. And they give me that a pair of sides are congruent. That's pretty good. So I'm going to mark that on my picture, X, Y, and Z, Y. All right? Oliver.
Yeah.
Because I have, I'll say this. Okay. Where do you want to start? Where do you want to go from, like I just wrote my givens down. Cool. Where have I been going after that?
I don't know.
Okay. You have 2 options. You can either use your givens or you can use your picture. What do you want to do first?
Oh, given.
Okay. So this is a congruent statement right here. So like I've already used that for its worth, right? So let's look at my other one. This means perpendicular. What does it mean if 2 lines are perpendicular?
They.
WY is perpendicular to XZ. What do they do? What do they form? They're helping you out, Oliver.
Like, I thought it was they add up to equal 90 degrees.
Nah, that's complementary.
Oh, yeah.
If they're perpendicular, they cross each other to form 90-degree angles, okay? So what we're going to do is we're going to state that in our proof, okay? So what angles are 90-degree angles?
Oh, I got it.
Go.
XWY and ZWY.
So notice how I wrote this. I just said angle XWY, comma, angle ZWY are right angles. How do I know they're right angles? What's my reason?
Go 90 degrees.
Some about perpendicular stuff.
So what about perpendicular?
Angles.
Definition of perpendicular lines. It was given to us that those lines are perpendicular to each other. Because of that, we knew it formed right angles. All right, well, if those angles are right angles, then what type of triangles are they in?
Right.
Right triangles. So this is why I said it's a little awkward. But now what I'm going to do is literally rewrite that same statement. But everywhere that there's an angle, I'm going to change it to a triangle. So I'm going to say triangle XWY, triangle ZWY are right triangles. Because I need to state that to use HL theorem.
Use what?
HL theorem. So how do I know to use HL theorem? Because I'm given a right angle, so there's a good chance that I'm going to use HL theorem. I should have done a little bit of planning with you guys ahead of time. XWY, ZWY are right triangles. How do I know that? We can just say definition of right triangles. We're going to go back up and do a little bit of planning once you guys finish writing that down. I probably should have done this to start the problem off. But if I look, like, okay, I've got those two sides congruent. I know that these angles are right angles. What other piece of information can I get? I've used my givens for all they're worth. Can I get anything from the picture? What can I get from the picture? WY is congruent to WY, right? I can get a reflexive side from the picture itself, okay? So I'm going to go back and state that. I'll just say it now. So WY is congruent to WY. Why? Yeah.
Wait, how did you know that you could get that?
Anytime you have a reflexive set of sides in your picture, you can always use that.
Okay.
So it was simply because of how my triangles were connected to each other. Not all triangles are connected like that, though, right? Like in this case, they didn't have a reflexive side. What did they have instead? A vertical angle. So those two things you can get for free anytime your picture has one of them. Not every picture does.
Smart one.
Yeah. All right, so now let's go through and chase through what we did. We stated that our triangles are right triangles. Did I show my hypotenuses are congruent?
No. Well, yeah.
Which sides represent my hypotenuses?
ZY and XY.
ZY and XY, right? And that was one of my givens, so there's my hypotenuse congruent. And then did I state a pair of legs congruent?
I think so.
Yeah, it's WY, right? It's the one that Brielle told us about, the reflexive side. So did I show the things I need to show for HL theorem?
Yeah.
I did. Cool. I just need to write my proof statement then. So triangle XYW congruent to triangle ZYW. Reason for that is HL theorem.
How will we know when we use the HL?
That is a really, really good question. How do I know that I'm going to use HL theorem as opposed to one of the other four theorems, right? You can only use HL theorem with what type of triangle?
Right triangle.
So if you have a right triangle, I'll say this. It's not guaranteed you're going to use HL theorem, but it's possible. So you got to keep that on your radar as you're going through and proving it, okay? So like, had I done planning before I started writing my proof, I would have been like, okay, these angles are right angles. That's sick. And then I have that these are reflexive sides, and then these are there. What do we have? Could I use like side angle side? no, because that angle does not connect my two sides. So because I could not use side angle side, then I should think, okay, can I use HL theorem instead? And I've got my hypotenuses, I got a pair of legs, and then I got the right triangle. So that's why I'd use that. Carter?
So from now, like whenever there's two right triangles, you'll use HL theorem?
Not always.
When?
I could,
Only when they're,
like, I could still prove triangles that are right triangles to be congruent by side angle side, side side side, something like that.
so why do you use it for this one?
We used it for this one because I was able to, but not every right triangle is going to be proved using HL theorem. But every triangle that's going to be proved using HL theorem is a right triangle. Okay. All right. I won't talk about this very much because just for the sake of time, which went fast today, man. What happened? You guys saw this acronym in the past, CPCTC. And the reason that we looked at that before, it stands for corresponding parts of congruent triangles are congruent. So if I write that out over here, corresponding parts of congruent. This is not the best tool to write with. Triangles, that's thick. Are congruent. Here's what that means. If you prove two triangles to be congruent, even if you do it by like showing like side angle side, so you just show two sets of sides at an angle, what does that mean about all the rest of the parts? After you know the triangles are congruent, all the rest of the parts would be congruent to each other, right? So you'll see some proofs such that okay, let's say I prove these two triangles on the left to be congruent using what method? What method would I use to prove those triangles congruent on the left? Yeah, it'd be side, 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 right? So I have three sets of sides. Once I know that the triangles are congruent, what can I say about all the corresponding angles? They're all congruent, okay? So CPCTC says once you prove triangles are congruent, you could say that all the rest of the pieces are congruent. Okay, so if you see proofs that look like something like this, where they want you to prove a set of sides congruent or a pair of angles congruent, those are done by CPCTC. Okay. Okay, do all of them but 6 and 8.
What did you say?
Do all of them but 6 and 8. We'll save those for tomorrow. No, I don't think so. I know.
Probably never going to be able to go to a playoff round the rest of your career. Very rare.
That's not true. I'll get there eventually. My life is just a bit crazy right now.